Okay, here's a simple example of an energy problem worked out, kind of very detailed so that you can see how to get started on some of these. What we've got is a car which is coming along at 2 meters per second, hits a post, and it pushes in the bumper. Bad news. If the bumper acts like a spring with this spring constant, how far would the bumper be compressed? So here's what we want to do. First of all, I put the formulas over here so you realize which ones we're going to be using. Kinetic energy, potential energy due to gravity, maybe elastic potential energy. Write down your knowns and unknowns, okay, out of the problem. What we're looking for is the distance we compress the spring-like bumper. So first step would be calculate your total initial mechanical energy. It really is helpful a lot of times to draw a picture, okay, of your kind of initial and final states to get your mind around what kinds of energy would exist in each condition. So initially, we just have our car rolling along the flat ground. So you ask yourself for your total mechanical energy, do you have kinetic energy? The answer would be yes, I do. Do you have any initial potential energy due to gravity? Well, on a level ground, when we're not going to change heights, you could say no. You could let that height be zero. And same thing, there's not a spring energy involved in the first part here. It hasn't been compressed or stretched yet when it's just rolling along the ground. So there'd be 0 joules of energy stored in the spring. So that's your total initial mechanical energy. Then you get to the end, and what's happened is the car has hit the post and has compressed the bumper. So at that moment, the car wouldn't be moving at that maximum compression. So our final energies would not consist of any kinetic energy, since our velocity would be 0 now. Again, we haven't changed any heights, or there's no height here, so that's 0 joules. But all of the energy is now stored in the compressed bumper or the compressed spring before it might spring back. So at that point, we can set our total initial mechanical energy to our total final mechanical energy, assuming we're not losing energy to friction and different things like that. We should conserve it. So setting this stuff here equal to the quantities that we categorized over here, we should come up with our equation, and it simplifies to just the kinetic energy all being turned into spring compression energy, elastic energy, and we just do the algebra, plug in what we know, 2,500 kilograms for the mass, 2 meters per second for our final velocity, or our initial velocity, I'm sorry, and our spring constant, and that should give us an answer of 0.05 meters, or does that seem reasonable? 5 centimeters. Seems like that could work.